Welcome to Study Loop.
All right, so we've got this river, right? Let's get a more rivery color. I don't know, blue. Okay, we've got this river, and a boater is on the shore of the river, and he'd like to end up across the river at the same spot. Not a little bit to the left, not a little bit, neither up nor down river. Okay. That's the goal. Okay, then we're also told that this river has a speed, right? And that is 9 miles per hour, and that's to the east. All right, so we're going to say north, east, south, west, right? It's around the south shore of the river. Okay, and yeah, so we could represent that speed, say, with a vector, right? 9 miles an hour to the east. Let's say, let's say that's 9 miles an hour. Okay, so that's a velocity vector. Now, we're also told that we have a boat. That's what we're going to be using to cross the river. And that this boat has a top speed of 18 miles per hour. Okay. So, no matter what direction we point our boat, it's going to have twice the magnitude of our 9 mile an hour river, right? So, if we pointed it to the right, it would look something like this, right? If we went east, this would be our velocity vector for the boat itself, right? It wouldn't be the total velocity vector. In fact, the total velocity vector would have to sum up all the velocity vectors. But the idea is that we basically got this much speed to work with. Okay, so how are we going to do this? How are we going to end up getting to the north side of the river? Okay, I'll call this 18 miles an hour. Okay, how are we going to end up getting to the north side of the river without going up the river or down the river? Okay, well, what we're going to need is a velocity vector that is in a net fashion purely north. We need our velocity to not have any western component or eastern component. How are we going to do this? We need our boat's velocity vector to be to the east to some regard, to some extent, that the it will have westward velocity that's equal to 9 miles an hour. Okay, what do I mean by that? Well, let's say, what if we faced our boat directly west, for example? Okay, what if we said, okay, our boat is going to go 18 miles an hour up the river in the westward direction? Well, remember when we do vector addition to find out what our net velocity would be here, we do tip to tail addition of the velocity vectors, right? So we could take, let's take the boat or the river and do tip to tail with our boat, right? So this is the addition that we do. I'll shorten this a little bit. Okay, it's about half. Okay, right. So when we add these together, our net velocity, right? These parts are going to cancel, and we're going to end up with this, our net velocity. Sorry, uh, this is our net velocity. It's going to be purely westward, but it's only going to be 9 miles an hour, right? So what we need to do is angle our how do I do that this way? Change the angle. There we go. Angle our velocity vector such that when we do tip to tail, right, that the westward velocity we created cancels out with the eastward velocity of the river. And so all we're left with is northward velocity. We don't have any net west or east, right? So that's what we need to do. We need to angle our velocity such that the westward velocity is equal to the east. The westward velocity of our boat is equal to the eastward velocity of the river. Okay, and we do this with a little bit of trigonometry, right? So we know that this is going to be 18 miles an hour. We know that this is going to be 9 miles an hour. Okay, so what we need to know is what angle are we going to put here, um, such that the component, right, of the westward component of this arrow is equal in magnitude to the component here, right? Uh, yeah, so that's what we need to do. Okay. So what we're basically doing is a triangle problem. We're saying, okay, we've got 9 down here, we've got 18 here, we've got something here. We don't really know what's the angle here, right? So we know that we have the hypotenuse, right? And we've got the adjacent side. We don't know the opposite side, okay, of our angle. Okay, so this is like SOHCAHTOA, right? Um, Sine opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, well, the sides we have are adjacent and hypotenuse. We've got 9 and 8, and we need to know theta. Okay, so we know cos theta equals 9 over 18 equals 1/2. Okay, so basically, what is theta if cos of theta is equal to 1/2, right? That's pi over 3. We can do that with arc cos in a calculator, or maybe we just memorized or trigonometry, have you? That's pi over 3. Okay, so in degrees, that's equivalent to 60 degrees. All right. Now, that is our angle above west, right? That is, we're going 60 degrees, like in that direction. I don't know how you need to enter that. It says n underscore degrees west. I don't know if you can just put 60 in there. I'm not really familiar with this nomenclature, right? The answer is 60 degrees above west. Okay.